Hello, my name is Marta and in this video I will explain geometric series. So how to calculate the sum of terms of a geometric sequence. Series, so the sum. To find the sum of terms in a geometric sequence, we have to use this formula. I will not get into detail on how to get this formula, how to derive it, how to prove it. That's a topic for a separate video. In this video I will just show you how to use it. Sn is the sum of n terms. So, for example, if I want to find the sum of 10 terms, that means that I want to find S10. Okay, that means that I take the first 10 terms and I add them up. So I do u1 plus u2 plus u3. Oh, I can't even list them all, it's too time consuming. So that's not what I want to do. If I don't want to just list them all and add. Just imagine that I want to find the sum of first 100 terms. That would be very painful. So I will just use this formula. In this case we have an example in which it's 2 plus 6 plus 18 plus 54 and so on and so on. But I will not list them all until up to the 10th term. Instead, I will use this formula. In this formula, A stands for A1, so the first term. The first term is, in our case, 2. So the first term is A and the first term is 2. So this is the first term. Now R stands for the common ratio. R is the common ratio. Well, this R is also the common ratio. It's the same R, but it just appears in the formula twice. So, one more time. The A stands for the first term. In the example that I prepared, the first term is 2. The R stands for the common ratio. In the example that I prepared, the common ratio, we can figure out that it is 3. So the common ratio is 3. Having the first term and the common ratio and knowing how many terms we want to add, we can simply substitute to this formula and find it. So we want to find S10, which means that we want to add the first 10 terms. And the formula goes like this. First, I take the A, so the first term is 2 times. Open the bracket, and in the bracket you have 1 minus the R, so the common ratio. In our case, the common ratio is 3, to the power of n. N is the same n as here, so how many terms you want to add? I want to add 10 terms, so I put 10 here. Now I divide that all by 1 minus R, and R is 3. And that's it. I substitute to this formula, use a calculator, and find the sum. So let's use a calculator. I have to do 3 to the power of 10, which is 59,049. So basically I have 2 times 1 minus 59,049 over 1 minus 3 is minus 2. So I have to do the next operation, so 1 minus 59,049, or you can use a calculator and just type in everything at once. It's up to you. I will just perform these operations and I got 59,048. That's the sum of the first term, 10 terms. If I add 2 plus 6 plus 18 plus 54, and I will continue adding up to the 10th term, I get 59,048. Whew, that's a lot. So definitely listing them all and adding them up is not recommended. It would be more time consuming. Let's take a look at the next example. Now we have to find the least value of n such that the sum of 1 plus 2 plus 4 plus 8 and so on to n terms exceeds 2 million. Okay, so let's try. I don't know how many terms I need to add, but I would like this sum to be greater than 2 million. So let's find this sum first with everything we have. I will copy the formula, or maybe I will just write it here. The sum of n terms is the first term times 1 minus ratio to the power of n divided by 1 minus ratio. This is the formula that we discussed here. That's the same formula. And now I would like to know when this formula is more than 2 million. I will just write down that it is equal to 2 million now, and then we'll pick the right solution, okay? So let's just check for which n it would be 2 million, and then match n based on that. Okay, I'm doing this because I just want to present my calculations in an easier way. So the first term is 1. The common ratio in our case is 2. I can see that I multiply by 2 to get to the next term. The common ratio is 2. What happened with my r? There should be r. Okay, it disappeared. So the common ratio is 2, it is in both cases here, but n is unknown, and that's how it will stay, because I want to find n. So let's simplify this. A is 1, so it's 1 times 1 minus 2 to the power of n over 1 minus 2. Let's see what else I have here. Maybe I don't have to write this times 1, so I will just multiply everything by minus 1. I will get then 1 minus 2n is equal to minus 2 million. I will move this here and this here, so I will get that 2n, 2 to the power of n is 1 plus 2 million. Which means that 2 to the power of n is 2,000,001. And now I have to solve this equation. We can write down, it's an exponential equation, so to solve it you have to use the strategy you learned in the chapter about logarithms and exponential equations. To solve it, we can just write down that a to the power of b is equal to c if and only if logarithm base a of c is equal to b. So I just write it as a logarithm. So log base 2 of 2002,000,001 is equal to n. That's my n. Now I have to find it. The best way to find it is use a calculator. So I will use a calculator. If you have a simple calculator in which you are not able to change the base to 2, and you can't type in logarithm base 2, then you change the base. You use the change the base formula. But if your calculator has this option to just type in this expression, you just do that. But if you cannot type it in your calculator, you just use this trick. Right? So this is the change of the base formula, which you learned in the chapter logarithms. Okay, but we can also just type this in the calculator using the button log AB. Logarithm base 2 of 2,000,001 is approximately 20.9. So we found out that for the sum of terms to be 2 million, we would have to have 20.9 terms, which is impossible, and is a natural number. You have the 20th term or you have the 21st term. There is no such thing as a term number 20.9. So you know now that the sum of 20 terms wouldn't be 2 million yet. It would be smaller than 2 million, right? The more terms we take, the bigger the sum. For 20 terms, it would not be it wouldn't reach 2 million yet, because we know that it reaches 2 million for 20.9. But then that means that we have to take the next sum. The sum of 21 terms would be more than 2 million. Okay? So if our n was 20.9, if that's our answer, and we know that n cannot be 20.9 per se, that means we have to take the number of terms right after 20.1, which is 21. So we know that the answer is n is equal to 21. We reject the answer which is not natural, we just take the next natural number, so we always round up, and that's the answer. And that's how you can use this formula in exercises. That's all for this video. See you in the next one.